Hey everyone, my name is Dexter Ferguson, and today we're going to be going over Lab 1 in the Geography 253 course. So Lab 1 is going to be focused on maps, and upon completion of the lab you will be able to analyze a map, describe the essential elements of a map, and examine a map for its key information and describe scale. In the manual, we have a list of key terms that you will be able to learn and describe as we progress through the lab. So, as I said, this lab is focused on map essentials. A map can be described as a way to get to point A from point B, or vice versa. They've been used since civilization started in order to locate things such as riverbeds, streams where animals tend to migrate during hunting season, the best places to plant early grain and everything. But how did maps get to where they are today from the simple beginnings they used to be? Well, now we have some essentials that can be found on a map. They can be a directional reference, such as a north arrow, a legend or key describing what the map has in it, such as if it is a topographic map, it might have a star on capitals of a state. It will have buildings, and the buildings will be in the key as well. If it's a thematic map, it will have colors and symbols as well, representing different things, such as in an election. Different states will be red and blue, depending on which way the states turned that period. Next will be a source. A map can be thought of as an academic paper. When you put something on the map, you have to source inside it. That way people know where you're getting your information from. Same thing goes for a date. You have to date your map. That way people in the future will know when it was created and what information in the map is currently relevant. And as another thing, like a paper, is you have to put your name on it if you design a map. That way people can look up your other works if they like the way you laid out your map, and it's just a way to keep track and sort different maps. Another essential is the projection of the map. We'll get into that later on. The scale of the map and the locational reference of the map. So, as I said before, first off, we got the directional reference. It can be a north arrow or rose in the corner of a map. There are two different types of references, directional references, we will be going over today. The first is true north. True north is a reference based on the star Polaris, and it's been the directional reference we've been using ever since we started using directional references. It is a star located in the northern sky, and it is always there in the entire northern hemisphere. The second directional reference is the magnetic north. As we know, the Earth has different magnetic fields, and so we can use those fields to determine which direction we are facing. That's how the compass works and many other electronics. Next we have the legend or key. Maps typically show big areas of the Earth on a small piece of paper. So without a legend or key, there would just be a bunch of shapes and colors on the map, and unless you were specifically trained, you wouldn't know what they were. Some different things that would typically be on a legend or a key are school buildings, churches, rock quarries, airports, an unimproved dirt road, swamp, and so on. Next we have the source of the map, and like I said before, the source is basically stating where you got your information from. It can be from other maps, it can be data that you've collected yourself, but you have to source where you've received the data. That way people will know where they can go back and gather data as well. Next we have the dates of the map. The date is useful because if you are doing a research paper or something on an area, let's say if you're in political science, you want to know which way the states turned in 1987 compared to how they turned in 1999. So if a map does not have a date on it, you wouldn't know which was which. So dates are very important for timekeeping and making sure that the information you're using is relevant. Next we have the name of the cartographer or the publisher. Just like an academic paper, you need to have your name on it as well. That way people can find your works, source your works, stuff like that.
Okay, Mr. King here. All right, now we're going to talk about scale and projection. Actually, projection first. All right, so when you look at a map of the Earth, you are actually looking at a projected image. We know that when you look at a flat map, that the Earth is not flat. There is no negotiation on this. The Earth is not flat. So when we look at a map, we know that that map is being distorted in some way, because realistically you cannot have a flat, incredibly flat surface on a large area. All right, so there are three ways that you can distort a map. So you can distort in direction, as you can see if you're following along in the middle of page 8 here. So if you want to travel between 2 points, it says that the shortest distance is typically a straight line, but on a map, that is not always the case. In fact, that's usually not the case. And this is because of distortion. That you have the map, and if you put 2 points on there, you know that because of the curvature of the Earth, or maybe because of certain geographic features, that it is definitely not the shortest point. All right. Additionally, we have distortion in area. So if you look at a typical map of the planet Earth, one of the prime examples of distortion in area is Greenland. Greenland, on most maps, looks enormous. It is greatly out of proportion compared to other continents and other islands. And in this particular instance, we see this distortion because the majority of the maps that we see, especially here in the Northern Hemisphere, favor the Northern Hemisphere. So you will see larger proportions in the Northern Hemisphere than you will the Southern. Additionally, you will have distortion in shape. Distortion in shape. So the best way I can describe this is if you're looking at, if you were to take a globe and put it flat, just take a globe and just flatten it out. You would see that areas around the equator, where there is more area to cover on the map, tend to have a larger representation of their area. We see this with South America and Africa in particular, that on a globe they are technically misrepresented because they are not as large as they seem, where when you get to the North Pole or the South Pole, you see that the map starts to fold in on itself, and so you don't get a proper representation of that shape of whatever you might be looking at, whether it be the northern tips of Russia tend to do this, as do Canada and some parts of the southern hemisphere. All right, so we're going to move on to scale. And scale is important. You're going to find a couple types of scales, and we're going to discuss this. This is going to take up the rest of the lab here. So scale, and this is important, scale is a representation of Earth space to map space. A representation of Earth space to map space. If you're following along and taking notes, this is one of those things you're going to want to note, because you will hear this again. So we measure scale in a variety of ways. Typically, you will see a bar scale. You will look at a map. If you see some of the examples that we will be sending out along with this lab, you will see that they have a scale on the bottom, and it's a bar, and it has little dashes that help denote changes in distance. And what you can do is you can take a ruler, or you can take some other measuring device. I use my phone sometimes. You can use that and put it up to that scale, and it will be the same scale on the rest of the map, throughout the rest of the map. Doesn't matter where you put it. And that is easy for finding a distance between various points. Here in the lab manual, it asks you to find the distance between Martin Hall and the center of the square. You will see this on the PDF that we send along. And you will have to do that using a bar scale. And that bar scale is considered a graphic scale, so it is an image that shows you distance. And you can use that to find the distance approximately between 2 points. All right. Okay. The second type of scale we're going to talk about is representative fractions. So representative fraction will be 1 to a larger number. You will see this ratio on a map. You typically see this at the bottom of the map, typically very close to where the bar scales are. And the representative fractions are 1 of an object to a much larger number of the objects. So, for instance, I believe in the lab manual, it states 1 to 24,000. Now, you may be asking yourself, 1 to 24,000 what? What does that mean? What this means is that you can take one object that you have, any object that you can get a hold of, and on that map that you have, it will equal 24,000 of these. That can be inches, centimeters, feet, miles, shoes, pencils, it doesn't matter. You can use anything. In particular, you will find that these representative fractions tend to be on reference maps. These maps are ones that show you direct locations or precise locations at various locations. All right. So on page 10, you will see a few examples that it would like you to go through, and it will ask you how far 84,000 inches is to feet. You must know your conversions. There should be a conversion chart either in the appendix or should be attached somewhere in one of the PDFs with this. So be sure to pay attention to your conversions when you do this, and it will ask you certain points on the maps. Again, you will need to use the maps that we send along with you, the PDFs, when you go to do these. And that will help finish out the rest of the lab. And in the lab assignment itself, I do not see many examples of that, so just make sure to pay attention to the maps that we've given you, and all of the information that you will need to complete the lab assignment itself is in those maps. So, best of luck, and until next time.